green one, right?
Yeah, the green.
Hello. So RSVP Pop and Go is all about the state reduced or stateless, channelless traffic engineering with RSVP. So today we have generally two traffic engineering protocols capable of do things, and each of them has, when we look at them, there are different attributes like scaling or churn and exposure to the signaling churn, traffic engineering capability with and without central controller, etc. And you can quickly see that the reason why Spring is coming and why we invent the Spring is because we want to be more efficient on the scale, on state scale, and on the churn handling. However, with the RSVP, we can still do something good. When we look at the RSVP, which is mature and deployed, we can see that there is a one-to-one control plane state to label swap, so also data plane state. And every swap or swap to label is unique. It's a one-to-one relationship. This has impact on the data plane churn, right? When we have something going on the control plane, there is a lot of messages which manage the states in the ISIC. Remove next hop, add the next hop, etc. And with the make before break, it's even worse, because we have to create the new one and then take out the old one. So generally, the state as well as the churn is described as an n-square or O to n-square complexity. RSVP Pop and Go is a new concept which inherits some Spring label stack, but keep the RSVP control plane. As a result, we reduce the number of states and consequently number of the churn needed between control plane and data plane. How it works? We allocate the labels per the neighbor or per interface, similar to the adjacency seed. So then, in data plane scaling is linear, is O to O of M, and where M is the number of the direct neighbors. It doesn't depend on the scale of the network. And even more, the labels could be shared between LSPs. Also, if we resignal or optimize LSP by upgrading the bandwidth or whatever, if given node has the same egress interface for the previous version and new version of the same LSP, there is no need to change the labels. There is no need to generate any churn to the data plane. So, there are some other goodies with the RSVP Pop and Go. We have built-in bandwidth-driven optimization. As today, without any controller, auto bandwidth or whatever bandwidth reservation works. At the same time, because it's RSVP, is fully compatible with the PCEP or whatever way of the central controller or traffic engineering controller you want to use. So advanced traffic engineering like diverse path or the bandwidth calendaring is still available. The other very important problem which this RSVP Pop and Go extension solves is a delegation of label stack compression. If you was on the Ron's talk yesterday or on Monday, you realize that the label stack could be deep, and that's a problem because of the MTU as well as because of hardware support. And the option to that is to solve it. The node on the way need to be an agent or delegate the stack expansion. One of the challenges is how to find it. And RSVP, because it creates the state and every node on the way is exposed to the control plane, this extension allows us to auto-select and delegate Pop and Go. And you can see it here in the example, right? There is 8 hops, so there should be 8 labels on stack, but hardware supports only 5. And 2 of them is, by the way, for the traffic, for the service level. So the fourth node and the whatever 8888 node are the one which extend when they do the swap and push operation extending the label stack. So with that, when we look at this table, which I showed you at the beginning, the first line, the control plane scale, we actually addressed it a couple of years back by doing some extension to RSVP protocol on with the self-ping, with the aggregation, refresh reduction, etc. It's not that bad. However, the push and go moves the data plane scale as well as data plane churn, move the RSVP to be equal in pair with the Spring. We have the same number of states on the nodes, proportional to number of neighbors, and we need the same number of operations when the LSP changes, as with the case of the Spring. So this proposal is submitted to IETF, so this is a reference to the draft. And if you want to play, just contact me or my team. We have the image, which virtual image, which could be used for the testing in the virtual environment. And I will be available outside after lighting talks. Thank you very much.